Hi, so today in this video we're going to be covering chapter 3.4.1, which is the division of polynomials. There are a few different methods for this, but the primary method that we're going to be talking about in this video is long division. Now, I'm going to quickly go over long division with this, well, not quickly, never mind. I'll go over it in depth. But there are a few things to keep in mind. Number one are the exponent rules. I covered them more in depth, I believe, last video, but briefly, it's like if you have x to the n times x to the m, that's the same as x to the n plus m. And if you have x to the m over x to the n, that's the same as x to the m minus n. And if you have something like x to the negative m, that's the same as 1 over x to the positive m. And if you have x to the 0th, that's exactly the same as 1. And then finally, if you have something like x to this m to the nth power, that is exactly the same as x to the m times n. Now, what we can do now is we can answer these first questions with that knowledge. This is really good review for division because you understand some of the rules that are involved. Here, this will turn into c. This will turn into z to the 1. This will turn into b to the 7th. This will turn into 1 over a to the 3, a cubed. Now this one's a little bit more tricky, but it's pretty much exactly the same idea. These go into each other, so we have positive 2, because negative 6 divided by 3 is going to be positive 2. And then we have c, because you have c to the 7th and c to the 6th. And if you, I'll expand it really quick. So we have negative 2 times, we'll do negative 3 times negative 2 times c 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 over negative 3 times c. And now we can do some crossing out. So we'll get boom, 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 boom. And that leaves us with positive 2c, which is what we decided. That's it. Very expanded. You don't have to do that. Sometimes it's helpful if you are not sure what to do. Next is c squared, c to the x, c times x to the 5th over 2 times x to the 3rd. These will cross out and become x squared, and these will cross out to become 3. Now we have b over 7b7, so that will turn it into 1 over 7 times b to the 4th. If you're confused by the things that I'm doing, I recommend going back over to the exponent rule, the video where I cover exponent rules, and I believe it's 1 or 2 chapters ago. Now this one will turn into 1 over 5, and then x squared, and that's your answer for that. Now we're going to be getting into some of the more tricky problems. This one's telling us to divide negative 2x to the 7th plus 6x to the 4th minus 8x to the 3rd by 2x cubed. A way to do that will be negative 2. I like to rewrite this. So negative 2x to the 7th plus 6x to the 4th minus 8x cubed. And all that's divided by 2x cubed. We can handle each of these separately. So 2x cubed and 2x 7th, we can look at it like this, negative 2x 7th over 2x cubed. And that can turn into negative x to the 4th, right here. So we have, number one, we have negative x to the 4th. And then we have 6x to the 4th divided by 2x cubed. And that will turn into 3x, so plus 3x. And then we have negative 8x cubed divided by 2x cubed. And that turns into negative 4. So that would be our correct answer, our new answer. Correctly divided. Same process here. This time I'll go quicker. I do like rewriting this. It just helps me to visualize things a little bit better. So this will turn into 4x to the 5th. This will turn into negative 2x. This will turn into 3 halves, positive 3 halves, just positive 3 halves, because the x is cross out. And then that would be your answer for this. Oh wait, whoops. Did I delete it? No, it's up here. My bad. Plus. And then find the quotient and remainder using long division. Okay, now this is the trickier part. I'm going to cover long division a little more in depth, and the rest of this video, I believe, we'll be talking about long division. And so, if you already know how to do that, you can go ahead and leave. If not, or if you want a review, just stick around for a bit. So, I like to, again, rewrite these equations. So, I have 2x plus 5. Now, if I had something like 2x squared plus 5, what's really useful is to add a placeholder for each term that you're missing in descending order. However, that doesn't really apply here since it's already in descending terms. That just helps you keep your place. It helps you make sure that you don't miss any extra important parts. So we have 8x cubed plus 16x squared minus 20x minus 25. And there's no placeholders needed in this one either. If we were missing the x squared, we'd want to do 0x squared. But in this case, it's not applicable. Now what we're going to do is we're going to solely look at our first one and at our first term and say, what can I multiply to my first term that will give me this term? And if you think about it, 2x times 4x squared will give you 8x cubed, because you multiply the coefficients and then you multiply the variables, and that will give you 8x cubed. So we want our answer to be 4x squared. So we'll put that above our placeholder slot that has x squared just to keep things lined up. So we have 4x squared, and now we can multiply 4x squared and we get 8x squared cubed, and then plus 20x squared. Now, when we're doing long division, if you remember, we're actually subtracting. And we need to subtract this whole thing. A common mistake people do is they just subtract this 8, but this 20 needs to flip signs as well. So, these cross out, and then this turns into negative 4x squared. And then, since we have two terms here, we want to bring another term down. So now we have negative 4x squared minus 20x. And now I say, what can I multiply this 2x by that will give me negative 4x squared? And that's going to be negative 2x. And we're going to make sure the placeholders line up. And so now we will have negative, and we're still subtracting, negative 4x squared, and then minus 10x. And we'll close those, and this will change all the signs in the middle. So these cross out, and these will give you negative 10x. And then we have two slots here, so we need to bring down another number. So there are two places. So now we have negative 10x minus 25. And now we say, what can we multiply this 2x by that will give us negative 10x? And that's going to be negative 5. So we will have minus negative 10x and then minus 25. And then these this subtraction foils through, and you get 0 plus 0. And this is your answer, and you have no remainder, so no remainder. But your quotient would be 4x squared minus 2x minus 5. I'm going to go a little quicker on this next example, but hopefully you'll still get the idea. So we have negative 5x. First I'll write the one on the outside, so x minus 2. And then let me move it over. Negative 5x cubed plus 6x squared plus 5x. And we want a plus 0. I know it doesn't make a lot of sense, but we just want the placeholder value. So now we're going to say, what can I multiply x with that will give me negative 5x cubed? And that's going to be negative 5x squared. And that will give me negative 5x cubed minus, plus 10x squared. And these will cross out, and this will give you negative 4x squared. And then we'll bring down another slot, so plus 5x. And then we'll say, what can I multiply to x? That will give me negative 4x squared. And that's going to be negative 4x. And that will give you negative 4x squared. And we're still subtracting that. And then plus 8x. And these will cross out. And this will turn into negative 3x. And then we'll have plus 0. And then what we can do is we can say, what can I multiply x with to get negative 3x? And that'll just be negative 3. So you'll get negative 3x and then plus 6. And this is still multiplied by a negative. And so now we can cross this out, and this will give you negative 6 as your remainder. And so what you do, typically, now this is different in Lumen, but the way that you would write this out, especially in 1050, and what I would assume like on paper quizzes, is you would write this answer out as negative 5x squared minus 4x minus 3 plus negative 6 over your divisor, which is x minus 2, over this thing right here. However, in Lumen, when it wants you to list the quotient, because this is what the actual quotient is, but in Lumen, all they want is the part that does not involve a negative. Not a negative, sorry. All they want is the part that does not involve any fractions. So we have negative 5x squared minus 4x minus 3, even though that's technically not quite the quotient. But then they'll say they want the remainder, and the remainder will be negative 6. Now, if it says that is wrong in that case, either make sure you did your math correctly, or it might want it in fraction form with this x minus 2, but I'm fairly certain that it just wants what this remainder is. So yeah, this last one I'm going to go extra speedy fast. So 4x plus 4, negative 4x cubed minus 2x squared minus 4x plus 2, and 4x will give me x squared. That'll give me 4x. And I want negative x squared. And then minus 4x squared. That cross out. Gives me 2x squared. And then minus 4x. And then what can I times 4x to get 2x squared? Oh, now this one's kind of tricky because now... Oh, that's a 12. Okay, that makes things a lot easier. I was like, wait, I don't think I've handled this kind before. But no, I don't think you'll see anything weird like that. So 8x squared minus 4x, and then that will give you plus 2x, and then that will give you 8x squared plus 8x. I'll give you, these will cross out, and that will give you negative 12x, and then plus 2, bring this down, and then 3, and it'll be minus 3, so minus negative 12x minus 12, and that gives you 14. So your remainder there would be 14. And the way that it wants you to write it this time is how I kind of said before. So the quotient is the negative x squared plus 2x minus 3, and then we'll add the remainder, which is 14, over 4x plus 4. And that should be your answer. Yeah, so I know that this one's kind of tricky and kind of heavy concept-wise. If you have any questions, please let me know, and I'll answer as soon as possible. Thank you.